Hello everyone. So in this tutorial, I'm going to discuss about a practical application we can do using Numpy and Pandas. So you got the basic knowledge on the Numpy and Matplotlib in the lecture, and I will introduce you the basic usage of Pandas and using Numpy. We are going to implement a simple exercise and a simple application. So simply what we are going to do here is I will show you the file that I'm having, and yeah, so this is the file that I'm using here, right? So here this contains math sample data set. So this contains marks like math marks, physics marks, chemistry marks of 20 students. So simply this is simply a sample data set, right? Okay, so this is in a CSV file format. That means like we can open it in the Excel. So what I'm going to do first, I'm going to load this into my code, right? So this is how it's done. So you can use Pandas library for this one. So Pandas is a very useful library in our this scope. I mean, this machine learning, deep learning scope. Pandas is very important library, and it's quite useful when it comes to dealing with data sets. Like if you have data sets in Excel files and like say data files. So in order to deal with data sets, the Pandas library is a very useful library we have, right? So this Pandas library, we will now, I'm not going to go through most of the functions of Pandas today, but I will use only one function. But in coming days, you may find you will study more functions from Pandas library. So I will use a function called read CSV. So read CSV is a very useful and a very powerful function. So what it can do is you can provide the path, right? The path. Now when you are giving a path, you can use this R character here. So this means the regular expression. Otherwise, sometimes the files might not read since this these characters and everything, sometimes it doesn't work. So the best thing is if you use R, then it will be quite okay. So if you are using, if you are going to load the file from a path of your computer, then please use R before the path, right? So then it will, without any issue, it will be loaded into your whatever the function, right? And my file is student mark CSV, so I copy it here. So I'm looking to load this file, right? And now I will show you what's the issue with this one. So then I will load it here for a variable or object called dataset, right? So if you run this one, so like this is kind of a Unicode error due to these characters and everything. So if you just put the R here, so this is a regular expression, and what happens is simply it without any issue it loads the data set. Now we can print it and see, right? We can print it and see the data set. So you will see the data set as it is, whatever CSV file as it is loaded into our object, this data set object, right? So when you're going to read something from the Pandas, it will be loaded as an data frame. So this is a data frame. This is not an array, right? So keep that thing in mind. This is not an array. This is a data frame. So this is not a Numpy array. So we can't do the things that we did with Numpy arrays, like the mean and the maximum value. We can't do that. But what we can do is, like without loading it like this, we can load it like this. Final, at the end, we can give something like dot values, right? So you can see dot values. Now, what's the difference between this and the earlier one reads the data set into something called Pandas data frame. So this is a Pandas data frame object. So you can deal with this with only Pandas functions. But if you put dot values here, what it does is simply it's converted, when it's loaded, it's converted into a Numpy array, a well-known Numpy array. So we are familiar with Numpy arrays than Pandas data frames. So Pandas data frames, you can deal with them, but you have to have the knowledge with Pandas. But now we are familiar with Numpy, and it's quite easy for us to use Numpy. And it's very easy to use Numpy arrays other than Pandas data frames, and we have lots of benefits using Numpy arrays than using Pandas data frame. So what it does simply, now you can see it's loaded to a two-dimensional Numpy array. So this is a Numpy array as we know, right? Now what I want to do here is to simply calculate the average of these marks and calculate the grades, like the maths grade, physics grade, and the chemistry grade for each student, and average of each student, right? Okay, so what I will do now, I want to get the average, right? So you know that we just learn these functions like np.mean, np.max, np.mean, those kind of functions, argmax. So similarly, we can use the mean, and you know that we need the average of these three, right? So then what I will do, I will get that part filtered by removing this first row, the first column, right? So what I'm going to do is I'm going to remove the first column. So, and I'm going to consider only the maths column, physics column, and the chemistry column. So as you can remember, we can use the slicing, and I can do it like I'm going to get not all the rows and columns. I'm going to get from not 0. I'm going to get from 1. So you know that this is the row number 0, 1, 2, and 3. So what I want to do is here I'm getting the row from 1 to end, or else you can say 1 to 4 or 1 to end. So no need to mention then, that means 1 to end. So we neglect the first column. We consider all the rows, but we neglect the first column and get the remaining thing. So it will simply get these three values, right? So then we have to see, we have to give the axis. So we need the axis. Which axis? So we need the column wise, row wise mean, right? So row wise mean, that means we need to go through the axis 1. So you know that I explained that this is the axis 0 and this is axis 1. So you want to go through axis 1. So what I give here is this, right? So now hopefully we should get the row wise maximum. So row wise maximum in the sense like this gives you the average of each student, right? We should give the average of each student, and I need to import the Numpy module, right? So this is the average of each student. You know, now this is a one-dimensional array here, right? So then what I need to do is I need to get the grades of each and every subject for each and every student. Grades for each and every subject for each and every student, right? So simply, in order to calculate the grade, I will use a function called find grade, right? Something called find grade, let's say. So this takes an input, this takes a mark as the input, right? And so if the mark is less than 35 and if the mark is greater than 0, so if this is in this range, the grade, I'm going to define the grade as F, right? And similarly, I'm going to give the other conditions as well, right? So here it should be equals, and so here also, if it is equal to 35 and less than, is it 45? Yes. Let's say it would become a S, right? So likewise, I'm going to implement the remaining things as well, like this, right? And here 45 and I think 65, it's a C, and B for 65 and 75, and here also 75 and here also equals to 100 gives the A, right? So finally what you can do, so this takes the input, mark as the input, and it returns the grade. So simple function, right? So what I do now, simply let me run this, and let us check for a sample value. Let me check it for the sample value, like 86, let's say 85, right? So it gives us the correct grade, right? Now, okay, what we have is a function which can give us a, once we upload the mark, it can give us a grade, the corresponding grade for that mark, right? Great. So what we are going to do now, I'm going to calculate the grades of each and every student. Let's say for maths, right? So I will create an array called maths grade, right? Math grades, let's say, right? Equal. So I will do something now, what we covered in our lecture, right? So what I'm going to do is, now you know what happens here. For I in range 10, right? So I will do this and show you, right? So what happens here in this kind of a thing, right? Something happens like this, right? So now I'm going to get the maths column, whole maths column, right? Whole maths column. So you can see it's the column number 1, right? So I will do something like this. See, for I in maths, sorry, I in data set, I'm going to consider all rows and only the first column. So that means what? All rows and the first column. So it will be the maths column. So this is what we use this slicing, right? All rows and only the maths column. So we take it here. So what will happen? I for I in data set. So what will be the output? Can you predict? Yeah. So this is simply the this one, 45, 44, 22, 88, 45, likewise. I in data set. So data set, all rows first column is simply the maths column, right? And we apply it here, right? I will do a small change. Without putting I here, I put fine grade I, right? See, so now what happens? I will be like each and every mark, and it will be applied to the fine grade function, and now here the grade will be returned. So the grade will be assigned to the array, right? See, very simple, right? So similarly, what we can do, right? Similarly, what we can do, physics grades, right? And it will be in column 2. You can see the physics are in the column 2, physics marks are in the column 2, right? And so you can see it as well here, simply, right? So those are the physics grades, and chemistry marks are in the column number 3. So you can get the chemistry grades as well, right? Simple, right? Done. Okay. So now what I do is simply, we have the grades. Now our data set, if you print, now we have the average grades and everything, right? What I will do, I will now print the data set. Data set, you know, it's something like this, right? So now what I'm going to do, I'm going to append these rows like, the maths grade, physics grade, and the average grade to this data set. So I'm going to add them as columns. I'm going to add them as columns to this one. So how you can do it? Now these are one-dimensional arrays, right? So what we need to do is we need to convert these things into two-dimensional arrays. So what I mean by two-dimensional arrays? So I will show you what I can do here. You can see this is a scalar, right? Oh, sorry, a one-dimensional array. This is a one-dimensional array. So I'm going to convert it to a two-dimensional array. Let's see how we are going to do it. You know the reshape, right? Reshape. So in reshape, we have a special command called, we can give like 1 minus 1 plus 1. So you can see I will print the both before the reshaping and after reshaping, right? The other thing is that you have to convert this into a Numpy array first, right? So you have to convert it to a Numpy array first. So I'm going to convert it to a Numpy array. Now this is a Python list. You can see it's a Python list. So you have to convert it to a Numpy array first, right? You can see now this is the normal maths grade and this is after reshaping. So minus, if you like minus 1 plus 1, it converts it to a column vector. What do you mean by column vector? So you can see one column, right? Column vector. Right? So this is called a column vector. And here, if you give like minus 1 plus 1, sorry, plus 1 minus 1, it will be converted to a row vector, right? So you can see row vector. So anyway, reshape plus 1 minus 1, from this you can convert a single dimensional array into a one dimensional array, but it can be a 1D, no, I mean it's 2D, but it's a row vector, either a column vector. So we want a column vector, minus 1 and plus 1, right? So we convert it as a column, right? So two-dimensional column, single column, but two dimensional. Can you see now? This is having a single column, but two dimensions, right? So this should be done for everything, right? I mean, the same thing should be done here as well. So I will get this like NP array. So here also you need to, yeah, done, that's done. And also this one also, you have to convert it to a, I mean, so you may have a question, why we are converting it to a column vector? Otherwise, how we can append it to this data set? So it should be a column, right? So that's why we are converting it to a column vector. Okay, so here also chemistry will be reshaped. So this is the into the purpose of like adding it to the data set. So we have to convert it to a column first. We are adding a column, this as a column, so we need to convert it to a column first. And also the average should be, I mean, converted into, so average, now where's the average? Yeah, so average is already a Numpy array. It's not a Python list, since np.mean, this gives Numpy array. So we have to just we have just reshape it. So we want to convert it to a column vector, so minus 1 plus 1, right? So now you can print the average as well. Let's see. Right. So let us print it and see as well. Right. Done. So it's also converted to a column. Now what we can do, we can simply use the function called append. Right. So I'm appending, right, the data set. I'm going to append the data. I'm going to append what? Let's attempt the maths grades, right? So I'm going to append maths grades, and you need to specifically mention into what axis. So you can see this should be append to the axis number, what, which axis? Is it axis number 0? Is it? No, it should be axis number 1, right? So you have to append it to the axis number. I mean, you have to append it as a column. So axis 1, right? So now if we print this, see, no, I have done this twice. Did I? Yeah, I did it twice. So accidentally I ran it twice. So it's appended twice. But you can do like, it can be simply, if you run this again, then it will be like all the things will be done again, and right now fine. So similarly, you have to append the remaining, like the physics grade, right, to the column axis, and then the chemistry grades again, right? So finally, append the average, right? Now finally, this is how it looks like, right? Now what we need to do, everything is done. So we need to convert it to a Numpy array and save it. I mean, this is already a Numpy array, so we have to save it, right? So we have a few methods of saving this. So you can save it using the np.save command, right? So new dataset, let's say new dataset dot, new dataset. So I'm going to save the dataset, right? So what this does simply, so if you go to the location, you can see a file is saved like new dataset.npy, right? This is the file that just created. So this is in .npy. Now you may wonder, you didn't give like new dataset.npy. You didn't give .npy part, right? But what happens here is that the .npy is automatically added. The extension is automatically added. So this is a numpy object. So we save this numpy object into a physical file. But the thing is, you can't view this. You can't view this .npy format. You can't view it. But thing is, you can load it in some other. You can load it into a Python code. You can't view it. You can't view it using Excel or anything. You can't view it, right? So if you run a test code like this, import numpy as np, so you can load it, right? Data equal np.load. So np.save, just save it. np.load, you can use it to load the data set. So let's see now data set, new data set, right? New data set dot npy, right? So now you will see, so this is very important, right? Okay, np.save and np.load. Yeah, so this is what it should do, but you run it, right? New dataset.npy. Do we need to pass some kind of parameter like this? Yeah. Now thing here is, now you can load it directly, but when the data file contains only integers or floats, if it contains like just numbers, right? If your array, the saved array, if it is only just numbers, you can load it like this. But if it contains something like strings and characters there, you have to use this allow pickle true. So you have to pass that keyword argument. So this is a keyword argument. Can you remember from functions, right? So simply what I did, I save it to a .npy file. So you can see if I go through, go to the location. So this is what I have, right? This one, right? So the new dataset .npy, right? Which one? New, yeah. So this cannot be opened from, I mean, CSV or text editor. If you go open with this, the text editor, you can see that it's a encoded type, right? So it's encoded. So you can't view this NPY files. But what you can do is you can load them in another code. Now, this is simply we save a NumPy array into a physical file, but they cannot be viewed. They can be only viewed from a Python code like this. So you can load that array. So array is saved a physical file, so we can load it in somewhere else. But thing is, this won't work. Like, I mean, for Excel files and CSV files, we can't get these things. So what we can do is we can use a method called np.saveText, right? Save text, right? np.saveText. But this also have an issue. Now here, let me quickly get the original code of this to check what I have included there. Now, the save text also gives an error. I will show you what the right. So you can use the command like this, save text. So this is the file name, and save text, you can save it to any Excel file, CSV file. So saves it to a .npy, but save text, you can save it to a CSV, Excel file, or anything, that file, anything. So this is the file name that we are using to save, and this is what you say, this is the array that you need to save, and this is the delimiter. Delimiter is the like so comma separated values. What it mean by comma separated? It refers to a comma, right? So CSV files, comma CSV, comma separated values. So it separates columns by a comma. So that's why comma separated. So if you can use other one, like if you are writing it to a, like, let's say a dat file, right? Dat file, then you can use spaces, right? Likewise. But anyway, this won't work, right? The thing is, you can save it to a CSV even, but this still doesn't work. The thing is that why we can't save it, due to this reason. Now it says this has like strings and everything. So it says if you have the NumPy array with different data types like number, I mean, if it is only numbers, it's fine. But if it is strings, that's also fine. But if it's a combination of strings and numbers, you can't save it to directly like this. So in that case, what you are going to do, you have to convert this back to a Pandas data frame. So here we actually loaded it to a Pandas data frame. Can you remember, right? But we converted it to a NumPy array using this. So here also now, since NumPy arrays cannot be saved into a CSV when there are numbers and strings together, what I do, simply I convert it to a data frame. So you can do it simply like this. You can use the command PD is pandas, function is data frame. So I'm applying the data. So keyword is data, and I'm applying this data array. So this is the data set array, right? So apply the data set array, and then you can see it's converted like this. And also you can use the column names as well, right? So here it doesn't have any column name, so we can use column names as well. So simply we can say columns, the names of the columns like name, math, physics, chemistry, maths grade, physics grade, C grade, average, right? So now you can see, right? And also now you can see indexes like 0, 1, 2, 3 is available. So what we can do here, another parameter can be given in order to remove these indexes, right? So that parameter simply index false. No, that's when saving that file, right? So now how you can save it? Simply you can save it using the df to csv function, right? So you can use df to csv. So that's something you can do with the data frame object. So data frame object dot to csv. So this can be saved like this, right? So index false, just remove this column numbers, right? So now if you go and check it, so you will have new data set, right? So dumped into a physical file, right? So if you do it like this, I mean, if you do it like this and run it without columns, right? So without columns, if you do it like this and run it, then you will see it like this, right? No columns, only 0, 1, 2, 3, 5, 6, 7. Okay, right? Understood? So that's how it's done, right? So that's how it's done. Yeah, right? So one final thing here, in the Matplotlib tutorial, I draw a histogram at the end, right? So I here from the pandas, I load the new data set, so the file just we created, and get the values. And from the data set, all rows, 7 column. What I mean by all rows and 7th column? So if you go here, all rows, 7th column. That means this average column. So we take the average and we plot a histogram here. See, we plot the histogram, and the histogram just give the distribution of the average marks. So it says like we have 10 bins like 10 to 20, 20 to 30, 30 to 40, 40 to 60, 89, like likewise 10 centers, and we measure, okay, how many are there between 10 and 20, and how many average marks are there between 20 and 40, right? How many average marks are there between 40 and 60, likewise. Understood? So that's simply how you can draw a histogram. Now this we can get the idea. So it says like the most majority of the average marks are like around 50 to 60, right? That's what it says. You can get the idea about the distribution from histogram. So this is how we are going to plot histogram. So we get the average and we pass it, and the number of centers, number of distributions we want. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 10. 1, 2, 3, 4, 5, 6, 7, 8. So 10 by 10. Okay, so yeah, so that's pretty much everything. And thank you very much. And we will meet with the next live lecture.